code where they got the steam plants or something there, facilities like hospitals and stuff there they use code B31.1. That's why it's called a power piping. What we use in our daily work here, most of the jobs we have, they're petrochemical jobs, so we use B31.3. That's the code we follow for most of the jobs. And 31.4 is for the liquid lines, pipelines, where they go miles and miles, straight lines going, because they are more liberal. You don't have to have support every so often. You can let them sag. You can just put them outside. It's cheaper. It lets you get away with the less expenses. And ASME 31.8, which is this one here. This is for the gas, but the same thing. It's the pipelines. It's for the gas, and 31.4 is for the liquid. So the other one is dumb, but anyway, we don't want to talk about that. Sorry, go ahead. Now these are the codes for basically for the equipment. So like I was telling you guys about, every piece of equipment has to be qualified for the code. So APA 610 is for the pumps. So you have to comply whatever the codes tell you to do. They have the tabulations, which you cannot exceed. They have their requirements for the pump, how it has to be manufactured, the sizes, dimensions, all this stuff. APA 617 for the centrifugal compressors, and 18 for the reciprocating compressors. 650 for the welded tanks. 661 for the air cooled heat exchangers. So NEMA is for the steam turbines. Good job. So these were, now we are away from piping, now we're talking how we support the pipes. There got to be some kind of designation, there got to be some kind of devices that we can physically control the system, how we can stop the direction we want to stop it, which direction it can move, which direction it cannot move. So for that, we have what you call it pipe support standards or pipe supports. There are supports, physically structured supports, which support the pipe. The first one here I'm going to go through, then we'll go in detail, is what we call them anchors. Anchor is a device which holds the pipe longitudinally. By longitudinal means is along the length. If this is the whole length of the pipe, we want to stop somewhere in the middle so it cannot move beyond that. We put stops on that one, so along the length of the pipe we can stop it where we want to. The guides, they're transverse, they're from sides. We don't want the pipe moving sideways. This is what we call the guides. And then there's struts. We will see in the later up there, snubbers. These are the devices where we cannot have a solid steel where pipes can pivot. The support can pivot. And then we got spring, actually spring hangers. But just remember that name as spring, then when we get later, we'll show you guys the picture and what the function of each support is. And the simple supports are, which we call them pipe support standards. Those are predetermined. We have designation for them. We don't have to calculate. We don't have to redesign all the time. They're standards. Whatever we need, we call the number, put it on the drawings, fabricator knows what to build. Okay, now this is the directional anchor we're talking about. Just as it says, it control, restrain the pipe from movement in the longitudinal direction. So that's the function of a directional anchor. And we'll see the picture on the next page, how it looks like. See, here we got the structural steel, and we have welded the lugs on the either side of the steel so that the pipe cannot move across. So this is how we isolate the piping portions where we don't want the lines keep growing. And the same thing is here. So this is how this comes strictly by the it's pipe sport standard. We already have them, and all you got to do is call out their number, and they will know what to do. The next one is the guide. Yeah, this is like we talked about. This is the restrain the pipe in the transverse side, and they're just like the anchors, but they're in a different direction. So, and they do help to prevent the buckling of long pipe runs. They just keep in line the pipe. So this is how they look like. The guides are on the side of the pipe. If you look at here, they are either side of the pipe. The anchors were along here. They stop on the inlet of the paper. The guides are the sideways. They stop it. So now this is a kind of general cookbook chart here. It tells you what size pipe you can, how far you have to go before you put the next guide. It just limits your distances. For this side, you can go 60 feet for the next guide from one to another. You don't have to put on every sport. On the pipe racks, in this business, usually every sport is 20 feet. That's pretty common. So, but with these sizes, you can skip a couple of sports for the guides. You can go every third one here, every fourth one here, and every second one for this size. Now this is what another device which controls the pipe. So you want to hold the pipe in one direction, but you don't have the steel close by. Let's say your steel column is there, your pipe is running here. You can't bring the steel that far. So what you do is you weld this part to the beam further down and hook up, clamp here to the pipe. So in this direction, it's very stiff, so it will stop the pipe. But the pipe can move the other direction because it's a pivot point. This is a pivot point, and this is a bolt going through here at pivot point. So this can swing left and right, but along the length, it will be stiff. It will not let the pipe go that way, or it will not let the pipe come to this side. The pipe can't go this direction, but it can move up and down, and it can go sideways. So it controls where you don't have the structural steel close by. This comes handy. The next one, yeah, this is just a definition of just to restrain the movement of pipe in one direction while providing for the movement due to thermal expansion or contraction in another direction. Now this looks like the same deal what we saw as a strut, but this we call it a snubber. What the function of the snubber is, if you look at the picture, it has a little chambers back here. These are called they could be mechanical, they could be hydraulic. What they do is, their function is that pipe can move due to the temperature. If the pipe is getting hot, it will let it go. Pipe can go in any direction here due to thermal growth. But if you have an earthquake, it will lock. It will not let the pipe deflect. So these were mostly used on the nuclear power plants, and if anybody ever seen any picture of the nuclear power plant inside construction, they were using everywhere, because if any earthquake comes along and they don't want the pipe to move, because those are designed for high accelerations up to 7G. San Onofre was designed up to 7G. And so they were used quite often because you can't put guides everywhere because due to the high temperatures, if you try to hold the pipe with a guide, your forces are tremendous. Your stresses are tremendous. You are overstressing the systems because in the room, in the power plants, you don't have much room. You make it 5, 10 feet this way, 7, 8 feet that way. So pipes are very stiff. So you want them to be free. So this device allows the piping to be free under operation. Temperature could be high, it can flex, it can move, it's relaxed. But for earthquake or wind, as a matter of fact, or any slug flows, any disturbance in the piping, it will lock up right away and keep the pipe in place. Yeah. This is the definition of the snubbers are used to restrain piping from suddenly applied loads, such as caused by slug flow, seismic, wind, but allow the motion for thermal expansion. Yeah. Next. Now this is the springs. It's an interesting little device, and believe it or not, a lot of designers who've been doing it for 20 years, they don't even know what the heck spring does. Every time we say, hey, it's not working, they would say, put a spring. So this is something like everybody got a aspirin or Advil at home. Anybody have a pain, give it Advil, you know. So this is commonly people say, oh, go ahead, don't worry, just use that. Now springs are used, it's a spring hanger that used where required to relieve sensitive equipment from gravitational effect of piping and other components. In other words, what it is, the spring supports will carry the weight only. It will allow the pipe to move. If you got from the vessel coming 30, 40 feet pipe coming down, it will compress with the pipe. But thermal loads, it will compress and will not have no loads on the nozzle, but it will pick up the total weight of the system. It picks up the weight, but for the thermal growth or contraction, it will give in. But it will always carry the weight within 15-20% of the variation shift in the loads. So there the springs are used. Let's see the picture here. These are different kind of springs, the same design except different application where you're attaching it. If you got your beam is way up here, they use a hanger rod in here and the clamp to the pipe here. This is here the same, you got different kind of connection here. This is here is the same deal. The steel is right here, the clip. So they're different adjustment, but the function is the same. All these different types, but all they're doing is picking up the dead weight of the piping only. They're not holding the pipe in any other direction. They're just carrying the weight, and they'll let the pipe move. Now this is called, it's the same spring, but these are called constant spring hangers. A constant, the difference between a variable, the one we saw before, and this constant spring hanger is that with the variable, the one we just saw before, they allow anywhere from 5 to, they're allowed to vary 25%. So in other words, the load from one to another could vary 20 to 25. They can dump their own load what they have on the next one up to 25%. It's just like when you guys have tug or rope, people are, pulling from both sides, and somebody get tired, they just relax. So what happens? The next guy has to hold it stronger. He got to pull more. So same way with the variable springs. But this device is expensive, but these are called constant. It does not matter what happens to the system. Pipe can move, whatever can move, but they will maintain to carry the same load what you're designed to. If you design that and set it up to carry 5,000 pounds, it will carry 5,000 pounds all the time. it has a device built in inside here. It's a spring in here. So these are used where the movements are much higher. If the pipes are growing more than 1.5 inches, they can go up to 7, 8, 9 inches deflections. The pipe can go up and down that much. So this kind of shows the application, how they look like. These are the variable springs. Here we have the steel up here. This is a variable spring with the rod and the clamp. So pipe stress engineer, by the way, these are catalog items. So nobody has to design anything. You pick up a catalog. Catalog shows you how much load you have. Stress engineer calculate what the total weight has to be carried by that support. Based on that, they got a chart. You can pick up a size of the spring, and then you know the dimension where the steel is, where the pipe is, so you build up the whole assembly. Okay. And this is the type when there's no overhead steel and the pipes are closer to the ground. So you come up with the dummy support, and then this is called a floor spring, So this carries up and down load this way. And this is basically, this assembly is used when you got vessels. You got a pipe coming along from the top, the column. You can pick up with the lugs here, the two lugs, two of them. If the load is 10,000 pounds, you use two of them, will be 5,000 pounds each. So, and they are very effective and they last forever, believe it or not. They're just like the shock absorbers under your car. Or you see in the front of the engine underneath, the springs, basically, there's nothing in them except just a coil. In the casing, it's just coil in there. Mm-hmm. Okay. Now we are into basic standard sports. Those were special sports. When the springs, snowboard, struts, those were special sports. These what we call is the standard sports. We want to support the pipe. The fabricator, they fabricate up to here. This is done in the field. So this is called a base support. Yeah. So here's the application, how they use those base supports. Here your pipes coming from the tank. They just support them underneath here. They just carry the weight. That's about it. And this shows that you can have a base support with a guide. If you want to hold the pipe in place, so you are adding those guides up here so that the whole system stays in one place. Whenever I use the word guide, that means whichever direction you are installing the guide, you want to hold it. You want to hold the system there so it don't move in that direction. So here's another typical pipe support. It's called the T-support. The pipe's up higher. They have used this beam here and put that beam here, put a U-bolt around it. So they will keep the pipe in place. That's a pipe support. And here are some of these are the modules of North Slope, Prudhoe Bay. Right now it's a ConocoPhillips, it used to be Arco. So these are inside the buildings. They call modules. And this is how these are supported right here. Is the dummy support or base support, how you want to call it. So they keep the pipe, pick up the weight of this whole pipe up to here to here.
It's welded to the elbow?
Yeah.
Does the bottom of the support or is it anchored as well?
Now this is all dummy supports here. They are welded to the pipe. This is loose. So, but you can use it either way. You can use just a support, or you want to hold it in this direction. You put a guide here and a guide on the other side. But if you want to hold it from the other direction, you put a guide here, guide up here, which probably previously we were looking at, this one here, same deal. You add these stoppers on the side. So those stoppers are welded to the plate. But this thing is free in the middle. the next one. So here we have got another special sports, you call them hangers. They're just as they sound, it's a hanger, it's the hang in the pipe. So pretty simple forward is, all it does again, pick up the weight. It would not help any thermal loading. It will not, because it's allowed to swing. It can swing sideways. If pipe can move up here, a lot of gap, but it will pick up the weight of this system here. And you design according to what kind of loads you have. And these are the insulated pipes. On insulated pipes, you can't put the pipe right on the steel, that will ruin the insulation. Because the insulation is not very hard, and it can't carry too much weight. So what they do is that they put the shoes on the pipes. They weld a shoe to the pipe, which is this one here, and they cut the insulation around it, and that sits directly on the steel. These we call them pipe shoe. And this is another kind of different kind of support coming from the vessel, and pick another weight of this pipe. This support is strictly welded to the vessel. The advantage of this one is there's no thermal loads. Even it's a hard contact. Usually whenever you have a hard contact support with the pipe, you're going to have the load. There's no ifs and no buts. Whenever the pipe is sitting somewhere, it's a hard surface, it's going to create forces there. But this one, the reason it won't have thermal loads, because this is coming right from the vessel or a tank. When this portion is growing up, this is coming back, it cancels out the thermal growth. If that piece of equipment up to this point is growing ½ inch up due to the temperature, it's moving up, it'll keep moving, but when it comes down, the pipe is growing too. So it cancels out at the same elevation. So half up, half down, at this point, resultant is a zero thermal growth. So you don't have thermal load, just the dead weight. And this is one we're supporting that from the columns. And the next one is the R, the system. You can support either from here, what we saw, or you can support it here. Sometimes some ASME vessel Div 2, they will not allow you to weld to the equipment, because they had to do that. There are a lot of requirements, post-well heat treatment or any other requirements. So you end up supporting the pipe here. Now you got a problem. Now you're going to have forces here, because this is growing up, this going with it. So it's going to lift up here. Because this steel not moving. This support is from the base here, on the floor. The steel is at the ambient temperature outside, 70 degrees or whatever you want to call it. But this column is moving up, so the pipe is going to lift off. So that's where we use the spring cans that we're looking at. The spring will go with it. The pipe will go up, the spring will go with it, and still will carry the weight. I think you guys are pretty much look like half of thinking, what the hell are we talking about? I tell you what, let's take a little break so you can